Okay, Rose curves are kind of important, so let's do a couple of extra examples of them. On these, we're just going to set things up. So it says set up an integral for the area of one petal of r equals 4 sine 6 theta. Now the 6 theta here tells me that we're going to have 12 petals. So we'll use that when we come up with our endpoints. Now as far as setting up the integral itself, the endpoints are the trickier part. The rest of it is pretty straightforward. Our area for this petal is going to be 1/2 integral of f of theta, so 4 sine 6 theta, this whole thing squared, d theta. And let's see, so it's going to be 1/2. I'm going to worry about my endpoints in a minute. This is going to give us 16 sine squared 6 theta d theta. And so that's going to be 8 integral sine squared 6 theta d theta. Okay, what about those endpoints? Let's work that out. If we look at it, there are a couple of ways you can do this. Why am I trying to draw this? Let's look at it on Desmos. When I graph this, r equals 4 times sine 6 theta. We get this. And sure enough, if you count them, we've got 12 lobes. So what we need to do is find the theta where one lobe starts and ends. And it doesn't matter which lobe, but the easiest one is going to be the one that starts at 0 and then goes to, well, the easiest is going to be to do this first lobe. Now, I'm going to plot this again. 4 sine 6 theta. And notice we've got a total of 12 lobes. So there's 2 pi from one end to the other. From the, when you go a full revolution, 2 pi. So if you do 2 pi divided by 12, that gives me pi over 6. So I think pi over 6 is going to be where the first lobe ends. So let's try changing this to pi over 6. And yeah, sure enough, that highlights or it graphs that first lobe just in blue. So we could use as our endpoints 0 to pi over 6. And that works perfectly fine. If you wanted to, you could go from pi over 6 to 2 pi over 6, or I guess we call that pi over 3, 2 pi over 6. And that would get us this other lobe down here. And that would work just as well, but it's a lot easier to deal with 0 to pi over 6. 0 is my favorite number. It tends to be easy to plug into things. So that's going to be our setup there, 0 to pi over 6. And working this out would be exactly like the previous one. So I'm not going to work it out. We're just going to set it up. Okay, the next one is very similar. Set up an integral for the area of one petal of r equals cosine 5 theta. All right, so again, the part of the setup's really easy. It's just going to be 1/2 integral cosine 5 theta. Now I got to square that. I'll just put it here, d theta. But our endpoints are going to be the tricky bit. Now let's graph it and play with it for a moment before we try to work those out. I'm going to move this up so we can see it a little better. So cosine 5 theta. I'll just turn that one off for the moment. So cosine of 5 theta. Notice something here. Theta is just going from 0 to pi. So if I went from 0 to pi over 5, it gets us this bit. If I go from 0 to pi over 10, it gets us that. So here's what we could do. We could try to work out from pi over 10 to, let me, all right. So if we do this, if we go from 0 to pi over 10, it gets us that part. So notice that's like an angular distance there of pi over 10. So we could think of it as being like 2 pi over 10 or pi over 5 being the distance for a full petal. So if I go from, say, pi over 10 to 2 pi over 10, notice that gets me half of a petal. If we go to 3 pi over 10, that gets me a full petal there. So I could use pi over 10 and 3 pi over 10 as my endpoints. But here's what I want to do. I want to use a little bit of symmetry to make this easy. And let's go back and look at 0 to pi over 10. If we look at 0 to pi over 10, that gets us half of a petal. So what I want to do is, let's just use 0 to pi over 10 for our endpoints, and then we'll double it. One day I'll figure out what I'm doing. There we go. All right, so what I'm going to do is, I'm going to say 0 to pi over 10, and then I've got to double it for symmetry. And that's going to get us this bit here. That's 0 to pi over 10, and just doubling it for that. And so I guess I would rewrite this as integral from 0 to pi over 10 cosine squared 5 theta d theta. And that's it.